Welcome to the Specific and Latent Heat laboratory exercise. In this laboratory exercise, you're going to be measuring the heat capacity of water and also the latent heat of fusion of ice. The specific heat of a body is the amount of energy you need to raise that body by 1 degree Celsius. So Q here represents the energy, the heat energy you're putting in. Heat energy is equal to the mass of the body times the specific heat times the change in temperature of the body. Latent heat is a measure of the amount of energy you need to put in to change the state of a substance. So in our case, we'll be working out how much energy you need to cause ice to melt and become water. In this experiment, you're going to use a calorimeter, which consists of an aluminium can with styrofoam, a good heat insulator in it, and just a plastic ring around the top. You're going to measure the heat capacity of water by placing it in an aluminium can and stirring it with an aluminium stirrer. You'll need to know the mass of the aluminium. So in order to do that, you'll need to unscrew the little blue knob on the end of the stirrer, being very careful not to lose it. You can then take out the aluminium stirrer, place it in the aluminium can, and record the mass of the can plus the stirrer. In this case, it's 34.4 grams. Make sure that you write that down. You'll then replace the stirrer through the lid. We have a plastic lid because it helps reduce the heat loss to the surroundings. Okay. You're going to use a resisting coil of wire to add heat energy to the water in your can. So you'll need to work out how much heat energy you're adding. You can do that using the formula power is equal to voltage times current. You'll use 2 multimeters, one to measure the current and one to measure the voltage. So let's set up this equipment now. What you'll need to do is add the water to your aluminium can. You've already recorded the mass of the aluminium can with the stirrer in it. So add the water. You can do that at the tap, which is at the back of the lab. Fill it about 2/3 full. You need to make sure that the resisting coil is underneath the water. So weigh the aluminium can and stir up with the water in it. Record that mass, and from that you can calculate your mass of water. You then put the aluminium can into the calorimeter, which will reduce the amount of heat that is lost to the surroundings. To heat up this water, you're going to need to set up an electric circuit. You've been provided with a DC power supply and 2 multimeters. You need the electricity to come out of the power supply and into your resisting coil. The ammeter needs to be put in series with this resistor. So if you read on the power supply, it tells you that the current is about 2.2 amps. That means that we have to use the unfused setting on the multimeter because our current is larger than 200 milliamps. Make sure that you plug it across the unfused setting or you will blow the fuse in the multimeter. So we then have the current flowing out of our resistor and into our multimeter, which is set to the ammeter setting, and back into the power supply. So that's the circuit there. In order to calculate the power flowing through our resistor, we also need to know the voltage. Power is equal to voltage times current. So we put a voltmeter in parallel with our resistor. With the voltage, we can use the fused setting. Once we've set it up, we can just make sure that we've plugged in our multimeters the right way around by very briefly switching on the power. The current is reading a negative number, which means that we just need to switch these two cables over. Okay, as you're taking the measurements for the temperature, every now and then glance at these multimeters and check that the values are not changing too much. You should record what these values are because you'll need to know them to calculate how much power is being put into the water. For now, switch it off. Next, you'll need to set up the temperature probe. The temperature is going to be recorded on the computer using the Logger Pro and the temperature sensor. You can place the temperature sensor into the water through the rubber bung here. Make sure that the temperature probe is only touching the water. We don't want it to touch the resistor or the sides of the aluminium can. You can then plug the temperature sensor into your Logger Pro. And as always, when you're using the Logger Pro, you need to plug the Logger Pro into the power. And also into the computer with the USB cable. Remember to make sure that you have the cable the right way up. The picture goes down the bottom. And this can then go into the computer. When you've plugged it into the computer, you can open the Specific and Latent Heat template. You should then have a temperature versus time graph. We're now ready to start recording data. To record the data, switch on the power so that power is flowing through the resistor, and then hit collect so that the temperature probe is sending information to the computer. Make sure your temperature probe is only hitting water, and while you're collecting data, it's important to constantly stir it to make sure that the temperature of the water is in equilibrium. We don't want the water around the resistor heating up more quickly than the water further away. So we stir it constantly, and if we do that, we should get a nice straight line. You're going to need to collect data for 10 minutes. When you've collected data for 10 minutes, you can stop it collecting and you'll need to work out the gradient of the line. So to do this, you can click on the linear fit, and this will give you the slope for that line. You'll then need to work out how to use the slope of the line to calculate the heat capacity of water. When you've calculated your value, you can write it on the whiteboard, and then you can use other people's values in the class to work out an uncertainty in your value. For the second part of the experiment, you're going to have to come up with your own method to calculate the latent heat of fusion of ice. Ice can be gathered from the ice machine at the back of the lab. Remember that you don't want to add water with the ice when you add it to your calorimeter, so it's a good idea to dry your ice before you add it to the water. You'll also need to get enough measurements so that you can calculate your own uncertainty in the latent heat of ice. So you'll need to repeat your experiment at least twice so that you have 3 readings and can get an uncertainty in that latent heat.